This lesson is on graphing square root functions. So our main objective today is to graph a square root function by translating our mother function. So I'd like to start off this lesson here by looking at a quadratic, and this is the mother function y equals x squared. So in red here, I don't think you can see where my cursor is, but I'm hovering over line 1, equation 1. This line is highlighted, so this equation here is going to be graphed on the right, and I have the graph in red of y equals x squared. So notice I have a vertex at 0, 0. I also have some distinct points. If I move right 1 and up 1 from the vertex, I end up at point 1, 1 on the graph of the curve y equals x squared. I also have a point 2, 4. So if I went 2 to the right and up 4 from that vertex, I land here at 2, 4. Okay. Now those points are obviously reflected on the other side here. This is the point negative 2, 4. Now if I add 2 to this function, so I take this and I'm going to highlight now line 2. So here in orange, I have the graph of x squared plus 2. Notice that everything gets shifted up 2 units. So here's our vertex of that quadratic at 0, 2. But I still have all the same points intact. If I go to the right 1 and up 1, I should be at 1, 3. Okay? Now, if I subtract 2, so let me get rid of the orange one. If I subtract 2, and I highlight here, now I'm shifting everything down 2 units. Okay? So now I'm at 0, negative 2, and I have a point at, there it is, 1, negative 1. Okay? Now, there's a different type of shift that occurs when you take that value and you subtract 2 on the inside of the parentheses squared. Okay, so now I'm looking at line 4. So I have the line y equals x minus 2 squared. So the graph of this quadratic here actually shifts it to the right 2. So I'm just reviewing some of the transformations that you've already seen before. So now we have that vertex here at 2, 0. I can also still go to the right 1 and up 1 to graph a point, and then I can reflect it over here. So this is the graph, or the point 1, 1. Okay. Now if I add 2, here I get values that are shifted left 2, so this vertex here is now at negative 2, 0. Alright, so these are just, again, a really quick review of the mini transformations that you've already done. Okay, so you might be asking, why are we looking at a quadratic? And the reason is that if we look at our mother function here and then we graph x equals y squared, the inverse of that function, we end up with this parabola that faces outward to the right. Okay, so it opens to the right as opposed to opening up. Now, this is not a function, so we can't say that these are inverse functions of one another, but the graph of y equals x squared is reflected over the line y equals x, which is why we have this inverse here. It's just not a function because this blue graph does not pass the vertical line test. Okay. However, our square root function is related to this particular parabola. Okay, so let me scroll down here. If I were to highlight this next line, line 7 here, this equation is y equals root x, you're going to get the top half of that particular parabola. Okay. So you see how now it's in green here. I'm looking at the top half of that particular parabola. If I highlight the bottom, the last one, line 8 here, I end up with negative square root of x, which is going to highlight the bottom half of that parabola. So let's say we start with just the graph of x equals y squared. Okay, so you're seeing a parabola that opens to the right. This is obviously not a function, but if we restrict it and we solve for y here, we would take the square root of both sides. So we get the square root of x and the square root of negative x, right? So here, this is the square root of x. This is our most basic square root function. This is the mother function for a square root function. And then below here in line 8, if I take that value and I put a negative out in front, all that it does is it reflects that graph of the square root function over the x-axis. So it flips it over the x-axis. So again, here's your normal square root function. Once you stick a negative out in front, it actually flips it over the x-axis. Okay? Okay, I want to mention one final thing before we start graphing some square root functions. The graph of a square root function has some very specific points that lie on it, so I'm going to unhighlight line 8 and we're just going to focus on our square root function. Now this point 0, 0 is not called a vertex because obviously this is not a parabola that opens up to the right, it's just the top portion of that parabola. But we have a point called the end point, so it's at 0, 0. Now if I slide over 1 and up 1, I should end up at the point 1, 1. So let me hit right on it, there it is, 1, 1. Now I can slide over here 4 to the right and up 2, and I'll land right on the point 4, 2. There it is. Okay. Now likewise, I can also slide 9 over. If I slide 9 over and up 3, I end up at the point 9, 3. Okay. So we're gonna look at those table values as well, but these are some very specific points that make it quick and very easy for us to graph a square root function. Okay, so we're back to our note sheet now, and I want to take a closer look at our mother function y equals root x. So I started a table here of values. Now this table of values isn't very helpful to me because if I plug in x is -2, I get an imaginary number. So I don't want to pick any negative values. If I choose something like 2, I also get a number that's not that easy to graph. So I have the coordinate 2 comma root 2, which is tough for me to graph. So I don't want to use values like that. Instead, I would pick values for y and then solve for the x. So if we wanted to get values of y, like 0, 1, 2, or 3, we would have to square the y in order to get x. So y squared is equal to x. So let's square the y, we get 0. If we square 1, we get 1. If we square 2, we get 4. Square 3, and we get 9. So here are some of the special points that are going to appear on our mother function. So we saw that already, but I just want to reiterate that with a table. We have the point 0, 0, then 1, 1, then 4, 2, and 9, 3. So we can shift to the right 1 and up 1, right 4 and up 2, right 9 and up 3. Okay, so there's our graph of the mother function. Now let's fill in this table over here. So the endpoint of this graph is at 0, 0. Okay, now that endpoint also dictates our domain and range, because if you look at the endpoint 0, 0, every value of x that we plug in beyond that point is greater than or equal to 0. So our domain here is x is greater than or equal to 0. And our range here, the y values, keep increasing as well. So they go up to positive infinity, which means our range is y is greater than or equal to 0. Okay, now that we know what our mother function looks like, let's try to do some of the transformations of that mother function. Here I have the equation y equals root x plus 2. So I want you to think back to when we graphed y is equal to x plus 2 squared. So this was the quadratic here. Remember, when we added 2 on the inside here, it actually shifted the graph left 2 units. So this is the same kind of transformation that I'm going to see here. That endpoint is going to be shifted left 2 units. So let's draw a little quick sketch here. So our endpoint used to be at 0, 0. Now it's going to shift 2 to the left, and now we're at the coordinate -2, 0. Remember, we still have some special coordinates on this square root function that would let us graph this quickly. We know that we can move right 1 and up 1. Okay, so we'd now be at the point -1, 1. And we can also shift right 4 and up 2. So if I want to go right 4 and up 2, oops, don't know why I wrote it like that. So right 4, up 2. That means I'm going to add 4 to the x value from the endpoint and add 2 to the y value. So I end up at the point 2, 2. Okay, so that would be my next coordinate here. And then it continues in that same idea. You can plug in and go right 9 and then up 3. So if I added 9 and went up 3, now I'm at the point 7, 3. Okay, so that would be another point on this graph. It's kind of flat, but you get the point. So we have a domain here. Again, it goes back to our original endpoint. The x values here are all greater than or equal to -2. Our y values here are all greater than or equal to 0. This is going to keep increasing to positive infinity here as I graph additional points. So this is y is greater than or equal to 0. And again, it relates back to your actual endpoint here, which is -2, 0. Now in example 4, here we're subtracting 4 from x, which means that we're going to shift this graph right 4 units. Okay, so now our endpoint, which was at 0, 0, now becomes the endpoint 4, 0. Okay, so here let's fill that in, 4, 0. Now remember, you can get additional points here by going right 1 and up 1, so we should end up at the point 5, 1. When you guys actually have a grid, this will be a lot easier for you. You don't have to find the specific coordinates because you can just count boxes, but right now we're just providing a sketch. So then that's going to continue in this direction here. So we're not going to do more points on this. I just want to get the general shape here. But you can see clearly that the domain is going to be x is greater than or equal to 4. The range is also y is greater than or equal to 0, because this is going to continue as x increases, y will increase to positive infinity as well. So this is just a real quick sketch of that graph. Okay, our next example asks us to graph y equals the opposite of root x. Remember, this relates back to graphing y squared equals x. This was a parabola that opened up to the right. Root x is the top portion of that graph. The opposite of root x is the bottom portion. So really this is just a reflection of your mother function over the x-axis. So when I sketch this, I just want to see the general shape here like that. Okay, we can find specific points, but we do know that that's 0, 0. If we wanted to find an additional couple points, that would be the point 1, -1, and then over here we'd have a point 4, -2. Now, based off of our endpoint, we can list our domain and range. So if you see, our endpoint is still 0, 0. Now in this case, our domain is still all values of x greater than or equal to 0, because as you can see, x increases as we continue to graph this function. The range, though, decreases. So we start at y is equal to 0, and then we go down to negative infinity. So this is the range here is y is less than or equal to 0. Now in our next example, we have two different transformations that occur here. So see how we have a negative out in front of that radical? Well, this is going to flip it over the x-axis, just like it did in the last problem. So I'm going to abbreviate that and write it as f and then little x here. So this is a flip over the x-axis. We also have a value on the inside here, which we just talked about above, which is going to shift this to the right 4 units. So we have a flip on the x-axis and a shift right 4 units. So to sketch this quickly, our endpoint is now shifted right 4 units. So we are at the endpoint 4, 0. So let's go fill that in here. And we know that this is a reflection over the x-axis. So it used to look like this. Now it's going to look like that. So that's our general sketch here. And we can list our domain and our range. Now our domain of this function is going to be, again, all x values that are greater than or equal to 4. So it relates back to this value here. Our range is all y values less than or equal to 0, because this is going to go down to negative infinity. As x increases, y will decrease to negative infinity. So that's the graph for D. Now in example E, we have a different type of transformation because now we're trying to graph the square root of negative x. So the negative is now on the inside with x. So let's see what happens when we put that negative in front of the x on the inside of that radical. So here I've got the mother function in green, and here in purple you can see that now it's reflected, but it's just reflected over the y-axis. So when you see a negative value on the inside next to the x, it's going to reflect it over the y-axis as opposed to the x-axis. So for a quick sketch here, I'm at the endpoint 0, 0 still, but now it's going to open to the left. So that's the general shape of this function, and our domain and range are going to be a little bit different. We have an endpoint still of 0, 0, but now our domain is going to be all x values less than or equal to 0, because as you can see, we're decreasing the x values here. The y values, though, still increase to positive infinity, because this is going to get bigger and bigger and bigger as x gets smaller and smaller and smaller. So our range is y is greater than or equal to 0. All right, now in example F, we have two different translations here, and one is a little bit trickier to see than the other. Clearly we have a negative in front of the x, right, which is going to mean that we're going to reflect it over the y-axis, which I'll abbreviate as flip over the y-axis. Now for the other transformation, we have this 4 here. Students will see this as positive 4, so they think it shifts it left 4, but instead I'm going to factor out the negative from here, so I have the opposite of negative 4 plus x, okay, which is equivalent to the opposite of x minus 4. Do you see here why this example is going to shift this to the right 4 as opposed to left 4, even though that is positive here and we think of it normally as doing the opposite. If we factor out that negative, we end up with the opposite of x minus 4. So we still get this flip of the y, but this clearly indicates why we are shifting right 4 now. So when we sketch this, we would be shifting to the right 4, 1, 2, 3, 4, and so we'd be at the point 4, 0. However, remember, this is a flip over the y-axis. Normally this would look like that, but now we're going to sketch it where it opens up to the left instead. So that's our general shape for this particular function. Now the domain and the range, again, are listed based off of the endpoint. Our endpoint is the point 4, 0. Our domain here is going to be all x values less than or equal to 4. And our range is going to be y values that are greater than or equal to 0. Again, they relate both back to our endpoint here, and you can see it visually as well. Okay, in example G, we actually have two different transformations that occur here. We have a negative on the outside of the radical and a negative on the inside of the radical. Remember that the negative here on the outside is going to be a reflection over the x-axis, so I'm going to abbreviate that as flip over the x. Now, the negative on the inside also reflects the function, but this is going to be a reflection over the y-axis, so I'll abbreviate that as flip over the y. So let's say we started with our mother function, which is going to open up and to the right. Well, we want to reflect that. Let's do this first one here in purple. We want to reflect that over the x-axis, so that's going to look like this now. And then finally, we want to reflect the function over the y-axis, so now it's going to open down and to the left. Okay, so to the left and down, which means our endpoint doesn't change. It's still 0, 0, but our domain and range will. So our domain here is all x values less than or equal to 0 because it's opening to the left of x is 0. It's also going to be, for the range, y is less than or equal to 0 because, again, these values are going to decrease as x gets very small. So here is the graph for another kind of general function here when you have two different negatives, one on the outside and one on the inside. Okay, example H is actually a combination of f and g. So you can see from your function here you have a negative on the outside and a negative on the inside, which will reflect it over the x-axis as well as the y-axis. So we have a flip over the x and a flip over the y. Now remember, very similar to example F, we have this 4 on the inside. This is going to shift it to the right 4. If you're still uncomfortable why it shifts it right 4 even though it's positive, think of it as taking out the negative. So if we factor out a negative here, we'd have the opposite of negative 4 plus x, right? These are equivalent, which is the same as the opposite of x minus 4. So clearly now you can see that it's going to shift it to the right 4. We go the opposite direction of that number. All right, so if we were to sketch the mother function, shifting it right 4 means now it looks like this, okay? We also want to flip it though over the x-axis, like that, and we also want to flip it over the y-axis. So it's going to open down and to the left like this. So here is our final sketch. So it opens down and to the left, and its endpoint is at 4, 0. So based off of that, our domain is going to be x values less than or equal to 4. So all x values less than or equal to 4, and our range will be all y values less than or equal to 0. Now our next example has no reflections because we don't have a negative on the outside or on the inside of the radical. However, we do have x plus 3 here. So remember, this is going to shift it the opposite direction. So we're going to go left 3 units. And then we're going to introduce a new translation here. When we graphed x squared plus 3, remember that shifted that parabola up 3 units. So here, this is going to shift it down 7 units. So it always goes in the same direction as the sign. So here, because it's a negative value, we're going to go down 7 units. It's really important for you to understand we go opposite when it's on the inside of the radical, but we go the same direction when it's on the outside of the radical. So if we sketch this, our mother function opens up and to the right. This function will do the same because there are no reflections, but it will shift left 3 and down 7. So our new endpoint here is negative 3, negative 7. Now our domain and range is based off of the graph, so if we just look at our graph here, we have a domain of x is greater than or equal to negative 3 because we continue to increase x values. And as we increase x values, the y output will also increase to positive infinity. So this is going to be y is greater than or equal to negative 7. Okay, I'd like you guys to try J and K on your own after we do example L together. Just make sure you understand how the different transformations affect the graph and that you're able to draw at least a rough sketch at this point. Okay, now finally for our last graph, we are going to graph a function that has every single transformation listed possible. We have a reflection over the x-axis, we have a reflection over the y-axis, we also have a horizontal and a vertical shift here. Now horizontally, remember this 3 is actually going to shift it right 3. Even though it's positive, it's still going to go to the right because you can factor out the negative, and it's the same as the opposite of x minus 3, so that's accounting for the shifting right 3. And then, of course, that plus 5, we just keep the sign, so this is going to go up 5 units. Okay, so those are 4 different transformations here. So if you were to graph your mother function, it would start off looking like this. Well, we know now that it's going to be reflected over the x-axis and the y-axis, so it's opening down and to the left. But this is going to be shifted right 3 units and up 5 units. So we go right 1, 2, 3, and up 1, 2, 3, 4, 5. So that's where our endpoint will be at the coordinate 3, 5. And it shifts down and to the left, or opens down and to the left. So for our domain, we have all x values less than or equal to 3, while our range is going to be all y values less than or equal to 5 because it opens down and to the left. Okay, so now let's try to take all of these transformations and just summarize them. All right, so we have several conclusions that we can draw from when we look at the graphs of our square root functions. If we have a square root function of the form y is equal to the square root of x minus h plus k, we will always have an endpoint at h comma k. Okay. Now, because this function here is going to open up and to the right, our domain, which is again based off of where our endpoint is going to be all x values greater than or equal to h. Our range, I'm not sure why this is not listed, sorry about that. Our range is going to be all y values greater than or equal to k. Now, if you have a square root function of the form the square root of x plus h plus k, now your endpoint is going to be negative h comma k. But because this opens up and to the right, your domain is pretty similar to the last problem. We're going to have all x values greater than or equal to negative h, and our range will be all y values greater than or equal to k. Okay, now these next couple bullet points are here just to highlight some of the similarities and differences between some of your square root functions. Now, when you look at the graph of an equation, y is equal to the square root of x minus h plus k, and you compare it to the graph of a square root function of the form y is equal to the square root of h minus x plus k, you're going to find that both have an endpoint h comma k. And again, that is because here, if we factor out a negative, we have the opposite of x minus h. Okay, so we take the opposite here, we get h comma k. Now, the graphs are different though, because this graph here will open up and to the right, while this one will also open up, but it's reflected over the y-axis, so it's going to open to the left. So here, if we call that y1 and y2, They have the same exact endpoint, but y2 is reflected over the y-axis. Okay. And finally, if we look at the graph of the equation y is equal to the square root of x minus h plus k, and we compare it to the graph of the equation y is equal to the opposite of the square root of x minus h plus k, you're going to see that both of them have the same endpoint, hk. Now our graphs are different though, because if we label these again as y sub 1 and y sub 2, y sub 2 is the reflection of y sub 1 over the x-axis. So y2 is reflected over the x-axis. So here we have a graph of a square root function that will open up and to the right, while this one will also open to the right, but it'll open down to the right. So our domain would be the same for these graphs. Our range, though, will be different. Okay, we're going to finish off the lesson now by providing a general sketch for each of the 4 basic types of square root functions that you're going to see. So I want you to memorize these general shapes because it'll help you when you have to graph something like -3 minus the square root of, I don't know, 5 minus x. Something like that has a lot of transformations in it, but if you know what the general shape is, it should be very quick for you to graph this because all you need to do is find the endpoint and then graph. So let's start with y is equal to the square root of x. Okay, so up first we have our mother function, y is equal to the square root of x. So I know that this is one we've seen a lot already. We know that that's going to open up and to the right. So our domain here is x is greater than or equal to 0. And our range is all y values greater than or equal to 0. Now as soon as we put that negative on the outside of that radical, remember it flips it over the x-axis. So this is a reflection of that graph over the x-axis, which means it now will open down and to the right. And when we graph something where we have a negative on the inside of the radical, this time it's a reflection over the y-axis. So we flip this over the y-axis, so now it's going to open up but to the left. So there's the general shape here. Oops, I forgot to do domain and range. Coming back to example 2, the domain here is going to be x values greater than or equal to 0, while the range will be all y values less than or equal to 0. So this is important. The signs are going to switch based off of the graph. For example 3, our domain here is going to be all x values less than or equal to 0, while our range will be all y values greater than or equal to 0. And then finally, for number 4, we have 2 different reflections here. We have a reflection over the x-axis and over the y-axis. So if we reflect, let's go back to like sketch 1 here. If we reflect it over the x-axis, now it would look like this. And then finally, we reflect it once more over the y-axis. So our general shape here opens down and to the left. So our domain is going to be x values less than or equal to 0, and our range will be y values less than or equal to 0. Okay, that's the end of the lesson. So please make sure that you go back and you have each and every single one of these graphs along with the equation memorized so that when you get something like y is equal to -3 minus the square root of 5 minus x, that example I showed you before, when you get to this you can graph this easily because you know that this is going to be a reflection over the x and the y axis here, so it has to open down and to the left, and then all you have to do is find your endpoint and a couple other points on the graph as opposed to drawing up a table of values where you have to solve for x or y, and that's really, really tough. So make sure you have these memorized. Nice job. See you in class tomorrow.